We're learning how to use logarithms and the calculator to help us solve exponential equations as another method to the ones we've already learned. So you might also want to look at the video on equating indices for solving exponential equations. So we've got here 3 to the 2x minus 1 equals 28. So that is an exponential equation. And to solve it, we can use logs. So the definition of a log is going to be applied from our previous work. So if you haven't watched that video, go back and watch that first. And to rewrite the equation given in log form, we basically write it as the base is 3, so it's log to base 3 of 28 equals 2x minus 1. Based on the definition of a logarithm from our previous work. And we can start to solve that, and we want to get x by itself. So I'm going to flip the sides around too and add 1 to both sides. So log to base 3 of 28 plus 1 because I'm solving, so I'm adding 1 to both sides. Okay, simple solving equation techniques by using inverse operations. Then next, to get x, we have to divide by 2 on both sides. That will leave x on the left, and all of this on the right, all of it is divided by 2. So just to emphasize that, I'm putting all of that in brackets, and it's divided by 2. And this is the part where we use the calculator. So if we grab the calculator, I'm just using the Desmos calculator. All you need is a calculator that will actually do bases other than 10 or natural log, other than the natural log or log to base 10. This one will do log to base e, and things like a lot of CAS calculators, TI and SPIs and so on will do that as well. So this method really only applies if you've got a calculator that will have a base of 3 log. Otherwise, you've got to use something called the change of base rule, and that kind of gets a bit clunky after that. So assuming you've got a suitable calculator, we've got an answer there. So 2.017, if we round it to say 3 decimal places, so that approximately equals 2.017 to 3 decimal places. Solved.